Hi everyone, myself Venkatadivya studying in Sri Venkateshwara College of Engineering, Department of CSE AI, third semester. Today, in this video, I am going to tell you about the sparse matrix multiplication. First of all, what do you mean by sparse matrix? A sparse matrix is a special case of a matrix in which the number of zero element is much higher than the number of non-zero elements. As a rule of thumb, if 2 by 3 of the total elements in a matrix are zero, it can be a sparse matrix. Means here it is a special matrix in which you can see that there are more number of zero elements as compared to the non-zero elements. So this is the sparse matrix in data structure, which have to be converted into row, columns and values. Here values are the number of non-zero elements given in the matrix. Now, what do you mean by sparse matrix multiplication? Before we talked about the sparse matrix, now I will talk about the sparse matrix multiplication. Sparse matrix is a technique used to multiply matrices that have a large number of zero elements. Like as you know, it is particularly efficient for matrices when only a small portion of elements are non-zero. Sparse matrix multiplication reduces the amount of computation required, leading to the improved performance. Here is the matrix 1 and matrix 2. In first matrix we took the row and in the second matrix we took the first column. So we have to multiply first row and the second column of the second matrix. Then we will get the resultant matrix. Then in second step we have to take the second row of first matrix and second column of the second matrix. So we will get the second resultant row and column, and 15, 43, 5, 17 is the resultant matrix after multiplication of the sparse matrix. Here is the basic concept of a sparse matrix multiplication. In sparse matrix multiplication, only the non-zero element of the matrix are considered for the computation. If means a sparse matrix means the number of zero elements are more, but in multiplication we will consider the non-zero element of the matrix are considered for the computation. The result matrix will also be sparse with only the non-zero elements computed. The goal is to minimize the number of operations required to perform the multiplication. Here is the sparse matrix, which is divided into triangular matrix and diagonal matrix. Upper triangular and lower triangular matrix. Here are this is the classification of a sparse matrix, which will be useful. Now, how we will represent the sparse matrix? Okay, this is a sparse matrix representation. The sparse matrix are typically represented using a compressed sparse row and compressed sparse columns. Means here we will take the row and the column format. CSR format stores the non-zero elements row-wise along with the column indices and row pointers. CSE format stores the non-zero element column-wise along with the row indices and column pointers. Here is the sparse matrix, which is converted into the rows and the row offsets and column offsets. Here segments are there which indices the column indices and row sizes. Here we will represent the sparse matrix based on the number of rows and the number of columns in the given matrix. Here is the algorithm for multiplication of the sparse matrix. The algorithm for sparse matrix multiplication involves iterating over the non-zero element of one matrix and performing the corresponding computations. The result matrix is constructed by accumulating the products of the non-zero elements. The algorithm takes advantage of the sparsity of the matrix to reduce the number of operations. Like here is the matrix 1 and matrix 2. We will consider the row of the first matrix and column of the second matrix. We will multiply this both. For multiplication, we will take the first element of the first row and the first element of the first column we will multiply, and we will add the second element of the first row and second element of the first column of the second matrix. Like that we will get the resultant matrix. Now we will talk about the complexity analysis of sparse matrix multiplication. The time complexity of sparse matrix multiplication depend on the number of non-zero elements in the input matrix. For matrices with a low density of non-zero element, the complexity can be significantly lower than the traditional matrix multiplication. The sparse complexity of the sparse matrix multiplication is also reduced due to the sparsity of the result matrix. Here is the example of sparse matrix multiplication where you can understand better. Sparse matrix multiplication is commonly used in various fields such as graph algorithms, scientific computations, and data analysis. It is particularly useful when dealing with large-scale datasets that exhibit sparsity. Example includes the network analysis, image processing, and recommendation of the systems. Here is the sparse matrix example. Here is the challenges and considerations. The sparse matrix multiplication additionally memory for storing the sparse matrix representation. The choice of the sparse matrix representation format can impact the performance of the matrix algorithms. Handling irregular sparsity patterns and matrix structure can be challenging. These are the challenges and consideration of the sparse matrix. Now optimizations and techniques of the sparse matrix. Here are the format of the sparse matrix. Various optimizations and techniques can be further improve the performance of the sparse matrix multiplication. Parallelization to leverage multi-core processor and distributed computing system. Pre-processing techniques to optimize the sparse matrix representation. Hybrid approaches that combine sparse and dense matrix operation. Here is the sparse matrix format in which you can apply the sparse matrix and the formats. Conclusion about the sparse matrix multiplication is a powerful technique for efficiently multiplying matrices with a high degree of sparsity. It offers advantages in terms of computational complexity, memory requirement, and performance. Understanding and utilizing the sparse matrix can greatly benefit application in various domains. Thank you. I hope this video will be helpful for you. Please like, share, and subscribe.